So like I told you guys in the introductory video today, we know that a quadratic equation can have 0, 1, or 2 real solutions, okay? And if we looked at the graphs of those, like I showed you in the video, so this red one over here has 0 real solutions because it does not cross the x-axis. This graph right here, the green parabola, has 1 real solution because it only touches the x-axis once. And this blue one over here has 2 solutions because it crosses the x-axis twice. And remember, where it crosses the x-axis are the solutions to a quadratic. Okay? Well, there's something about the quadratic equation that can tell us how many solutions a quadratic is going to have before we even graph it. Okay? So let's look at the entire quadratic equation. We've got x equals negative b plus or minus square root b squared minus 4ac all over 2a. All right? We're going to use the quadratic equation to solve these 3 equations down here. And then we're going to notice something about its solutions and then a certain part of the quadratic equation. All right? So let's start with this first one over here. I've got negative 3x squared plus x plus 4 equals 0. Okay, so for that one, they've already plugged the numbers into the quadratic equation for you. I know that a is negative 3, b is 1, c is 4. Okay, that's already been plugged in. So let's go ahead and start to simplify here. I got x equals negative 1 plus or minus square root of 1. And then if I do negative 4 times negative 3, that becomes positive 12. And then 12 times 4 is 48. So that becomes plus 48. I had the 2 negatives there, so it became positive. All of that is over negative 6. So if I continue to simplify this further, I've got x equals negative 1 plus or minus the square root of 49 all over negative 6. Well, the good thing is that I know that 49 is a perfect square, and it's a perfect square of 7. So it would be plus or minus 7 in that part. So I've got x equals negative 1 plus 7 over negative 6, or x equals negative 1 minus 7 over negative 6. All right? Because remember, you got to include both. All right. So if I go with this first scenario, x equals negative 1 plus 7 is 6 over negative 6, which equals negative 1. Or x equals negative 1 minus 7 is negative 8 over negative 6. And that's going to simplify to, I got a negative over a negative, so it's going to simplify to positive 4/3. Okay? So I know that that's going to have 2 real solutions. Those are real numbers, negative 1, positive 4/3. That's 2 real solutions. And if I look at the graph, this is a graph of that function. Notice it crosses the x-axis at negative 1 and positive 4/3. Okay, guys? So that's what the graph looks like. So that one had 2 real solutions. Let's look at our next quadratic. And let's use the quadratic equation to solve it. I got x equals negative 6 plus or minus square root of 36. 6 squared is 36. And then I got minus 4 times 1 times 9. Well, 4 times 1 is 4. 4 times 9 is 36. So 36 minus 36 all over 2. So here I've got x equals negative 6 plus or minus the square root of 0 over 2. Well, the square root of 0 is just 0, okay? So we're not adding or subtracting anything to negative 6. It's just staying the same. So we got x equals negative 6 over 2, or x equals negative 3. Okay? There's only one solution there. All right? Now, if we notice this too, this is a perfect square trinomial. And if you were to factor it, it would be x plus 3 squared equals 0. And the only thing that you could plug in there to make it equal to 0 is negative 3. So it only has one solution. So the number of real solutions is 1. It's negative 3. And if I look at the graph, I notice that it only touches the x-axis once, and that's at negative 3. Okay? So let's look at our last one over here. We've got 2x squared minus 5x plus 4 equals 0. Well, I've got x equals negative 5 becomes positive 5 plus or minus the square root of 25 minus 4 times 2 is 8. and then 8 times 4 is going to be 32, minus 32 over 4. All right, so if we continue to simplify this, I got x equals 5 plus or minus the square root of negative 7 over 4. Okay, now guys, I have a problem. I can't take the square root of a negative number because nothing times itself would be negative. A negative times a negative is a positive, and a positive times a positive is a positive. So you cannot take the square root of a negative number. All right? So this one has what we call no real solutions. No real solutions. Whoops. There you go. No real solutions. All right? So it would have what we call imaginary solutions, but like I said, you're not going to get into imaginary numbers until you get into Algebra 2 and beyond, okay? So if I were to graph this quadratic, notice it doesn't ever cross the x-axis. That's why it has no real solutions, okay? Well, let's look at something here really quick, okay? So here, the part under the square root was positive, and that gave me two scenarios, plus the square root of 49, minus the square root of 49. So that gave me two different solutions. What was under the square root was positive, and it gave me two different solutions, okay? If I look at this one, what was under the square root ended up simplifying to 0. So I plus or minus nothing, so I was left with just what was in front of that square root, which gave me only one solution, okay? There it equaled 0, so that gave me one solution, all right? And then if I look at this last one, what was under the square root ended up being negative, and I had no real solutions, okay? So this part of the quadratic equation under the square root told me that this was going to have no real solutions because I can't take the square root of a negative number, all right? So the part of the quadratic equation that's under the square root is called the discriminant. That tells you whether or not you're going to have two real solutions, one real solution, or no real solutions. So to determine how many solutions the quadratic has, it is clear that we do not need to do the entire quadratic formula. The only part you need to look at is that part under the square root. That's the b squared minus 4ac. If b squared minus 4ac, that's the discriminant. If b squared minus 4ac is greater than 0, then there are two real roots or two real solutions. If b squared minus 4ac, or if the discriminant, is equal to 0, then there exists one real solution or one real root. And finally, if the discriminant, or b squared minus 4ac, is less than 0, then there exists no real roots. So that's what you need to know about the discriminant, b squared minus 4ac. If the discriminant is greater than 0, there are two roots, two real roots. If the discriminant equals 0, there is one real root. And if the discriminant is less than 0, there are no real roots.